In this next section, we will talk about the assignment problems. In other words, what do we have here? We have a number of people to do a number of tasks. And in this case, we want to minimize the total cost or the total task times. So again, we're going to look at this problem from the viewpoint of an example. In this case, we have an operation called the Fixit shop, and they have 3 projects that they need to have service. 1 is to repair radio, 2 is to repair a toaster oven, and 3 is to repair a coffee table. So we have 3 different workers with talents that can do the job. So each worker has a cost associated with that worker to do the job. So the objective here would be to minimize the total cost. So let's look and see what we have. In this case, we have our supplier, similar to what we had before, except we only have 1 person, so they can only supply 1 talent. Whereas demand for each of the project only requires 1 demand. Now, in other problems, you may see this demand change, or you may see the supply chain change. But in this case, we have our 3 people and our 3 projects. And then, as you can see, the assignments and the dollar value associated with that person being assigned to a particular project. So, what does it look like? Well, back again, we're going to let our I's equal the person and our J's equal the project, and we're going to we're going to minimize the cost subject to the supply of Adams, Brown, and Cooper, and the demand of projects 1, 2, and 3. So here's our objective function. And of course, our objective function relates each one of the connections between the individual and the project. That's where our variables are. And then that's subject to, well, my supply is, I am going to add my Adams can go to 1, he can go to project 2, or he can go to project 3, but there's only 1 of him. The same thing with each of the other people, Brown and Cooper. Whereas my demand says that I go from project 1 plus project 2 plus project 3 associated with the people can only demand 1 person. Okay, and then of course the last thing we have is our non-negativity constraints. So we take this information and we put it into our QM for Windows. And in this case, we're going to be doing an assignment problem. So we're going to select assignment. Okay. Once we select assignment, we'll get this screen. And here's the box in which I will input my data. Let's blow this box up. So I have Fixit. I entered a number of assignments, 3. And in this case, I'm going to have 3 people that are going to be assigned to 3 different projects. So the software does not allow me to put in the number of projects. So I've done that, and then again, I'm going to minimize this. So once I do this, I'm going to click on OK. Once I click OK, I'm going to get a screen where I'm going to have to input my objective function. And as you may recall, our objective function was 11, 14, and 6 for person 1, and so forth and so on. Now, once I do that, I'm going to go and look for my solver menu by clicking on data. And once I click on data, the solver menu will come up, and I'll select solver. And once I select solver, my solver menu will come up. All my data is already pre-placed into my dialog box. And then I'm going to click on solve. Once I click on solve, I'm going to get my solver results. I want to select answer, and I got to make sure I select this because it doesn't automatically become blue. And then I'm going to keep solver solution, and then I'm going to select OK. And once I select OK, I will get my solution. And note, in this case, I do not have to go to the bottom and select a solution. I have a solution, and here's my solution. I put person 1 on row 3, on project 3, excuse me. Person 2 on project 2, and person 3 on project 1. So, well, what are my costs? Well, let's look at what happens. So Adam goes to project 3, and if Adams goes to project 3, it costs $6. If Brown goes to project 2, the cost is $10. And if Cooper goes to project 3, the cost is $9. My minimum cost is 6 plus 10 plus 9 is $25. And so there you have the basics of the assignment problem. Have fun working these problems.